this video, I will consider one numerical on Thevenin's theorem. Find Thevenin's equivalent network for the given circuit shown below. This is the given circuit. We need to find Thevenin's equivalent circuit at terminal A and B. That is, Thevenin's equivalent circuit consists of one voltage source in series with resistor, and this is the terminals A and B. That is, we have to reduce this entire circuit only to the voltage and resistor. This voltage is known as VTH, that is Thevenin's voltage, and this resistor is known as Thevenin's resistance. So we need to find VTH and RTH for this circuit. Now let me explain how to find VTH. So VTH is nothing but the voltage between terminal A and B. It is also known as open circuit voltage. We need to find the voltage between terminal A and B. That voltage is known as VTH. So here we can observe that voltage across AB is nothing but voltage across 5 ohm resistor. So first let me calculate the current through 5 ohm resistor. If you find the current through 5 ohm resistor, that current into resistor gives VTH. So this problem can be solved in two ways, either by using loop analysis or we can solve it directly. I will try to solve it directly. So here terminal A and B is open, so no current flows in this terminal. So here J5 and 5 are in series. That combination is in parallel with this 3. First let me calculate the equivalent resistance of this circuit. That is R equivalent is equal to, here these two are in series, that is 5 plus J5. So this combination is in parallel with 3, that is this is in parallel with 3. The resultant value is in series with this, that is plus the value of this is in series with this, that is 5 minus J2. Let me solve this. That is R equivalent is equal to, so these two are in parallel, so it is nothing but product of resistance divided by sum of these values, that is these two, that is 5 plus J5 into 3 divided by sum of this, that is 5 plus J5 plus 3. So keep the calculator in complex mode. Choose option 2. So now let me calculate 5 plus J5, that is 5 plus 5i into 3 divided by, that is equal to, divided by, here we have 5 plus 3 is 8, 8 plus J5, that is 8 plus 5i. Let me calculate this. So it gives this value plus, we have plus 5 minus J2, that is this value is added with 5 minus J2, that is plus, we have 5 minus 2i. So this is the final value. So that is 7.19 minus 1.494 R equivalence. So now let me calculate the total current in the circuit. That is, let the total current is I. Therefore, I is equal to V by R. That is 10 angle 30 degree divided by total resistance. That is 7.19 minus J 1.494. Let me calculate I. So this is R equivalence. Here we can see that it is on denominator. Let me take inverse of this. So this is inverse value. It is multiplied with 10 into angle 30. That is, I can multiply this with 10. Shift, use this symbol. Here we have angle 30. Close the bracket. So this is the final answer, which is current, that is 1.015 0.906 I. .906 J. So this is the total current in the circuit. So as we see here, the current I will divide here, part of the current will flow here and part of the current will flow here. Let me calculate I2. Therefore, here I2 is equal to total current, that is I, into opposite resistor. Here I2 is flows through J5 and 5. The opposite resistor is 3. This is current division rule, into 3 divided by sum of these two, that is 5 plus J5 plus 3, that is 8 plus J5. 8 plus J5, that is equal to, let me calculate this. This is I value. It should be multiplied with 3 divided by 8 plus J5. Let me calculate this using calculator. So already we have calculated I, that is multiplied with 3 divided by, we have 8 plus J5, that is 8 plus 5I. So it gives 0.426 0.073. So therefore now I can find VTH easily, that is VTH is equal to 5 into I2, that is, so therefore VTH is equal to 5 into I2, or I can write VTH is equal to, let me calculate this. This is I2, it is multiplied with 5, that is into 5. So here it gives 2.133. 2.133, then 0.366 J, that is plus J 0.366. So this VTH is in rectangular form. Let me keep this in polar form. So always answer should be kept in rectangular as well as in polar form. So to keep this value in polar form, we have to choose, press shift this to where we have complex. So here it shows 4 choices. In that we need third choice, which is magnitude and angle. So press 3 is equal to, it gives the equivalent polar value, that is 2.164 at an angle of, we have angle 9.73. 9.73 degree. So this is VTH. So now to calculate RTH, here the voltage source must be short circuited. So here if I short circuit this, it must be short circuited, and we have to find the equivalent resistance between terminal A and B, that is known as RTH. Now let me calculate RTH. So the resistance between terminal A and B is nothing but RTH, and this voltage source should be short circuited. So in this case 5 plus minus J2 is parallel with this, that combination is in series with this, and whole combination is in parallel with 5 ohm resistor. So therefore I can write here RTH will be equal to, we have 5 minus J2, 5 minus J2 is parallel with 3, that is parallel with 3. This whole combination is in series with J5, that is plus J5, and that whole combination is in parallel with 5, that is whole combination is in parallel with 5. So let me calculate this. So here first let me calculate this, that is RTH is equal to, we have 5 minus J2 into 3 divided by 5 plus 3 minus J2, that is 8 minus J2, 8 minus J2 plus J5, that is plus J5, and it is parallel with 5. First let me calculate only this part. First let me calculate only this part. To open the bracket, 5 minus 2i into 3 equal to, divided by, we have 8 minus 2i is equal to, we'll get some value plus j5, that is plus 5i. So we'll get the value as, so this is the value of this is parallel with 5. So this whole thing is in parallel with 5. So that is whole thing is in parallel with 5. Therefore I can write RTH equal to this value into 5, 1.9411 plus J 4.735 into 5 divided by sum of this. So 5 plus 1, that is 6.9411 plus J 4.735. So so this is already, we have the result of previous one into 5, that is into 5 divided by, we have 6.9411 plus 4.735, 4.735i. So this is the RTH, that is 2.54, and imaginary value is 1.676. 1.676 plus J 1.676 ohms. So this is RTH. Now let me draw the equivalent circuit. So therefore we have, this is VTH and this is RTH. This is terminal A and B. This is RTH, which is equal to 2.54 plus J 1.676, and we have VTH and its value is already calculated, which is 2.164 at an angle of 9.73 volts. So this is the equivalent, Thevenin's equivalent circuit for the given circuit. Thank you for watching.